Welcome to CS1104 Computer Systems. This is the Unit 3 lecture part 3. During this lecture I want to show you just a few more tips and tricks for using the logism environment. Now during this unit we're going to get into a little bit more complex circuits, and I wanted to make sure that you kind of understood some of the features within logism that could kind of help you to develop those circuits a little bit more effectively. Now in particular what we're going to want to look at is using the splitter. So there's something that we have in logism that we refer to as the splitter, and what it allows us to do is one of the things that you can do in logism is you can kind of define a series of multi-bit inputs. So instead of having to draw a line for every bit, I can kind of define some of my devices and my gates as having 4 bits or 8 bits, 32, whatever the case might be of input. So I want to having one line that represents those 4 bits. Now in order to use them I need to be able to sometimes see those bits, and then in some cases I need to be able to break them out and get at them individually. So the splitter is a nice tool because what it does is it takes one input, one line that represents multiple bits, and it splits those bits out so that I can get access to the individual ones. And we're going to look a little bit at how do we set multi-bit inputs and outputs for gates and pins and things of that nature. It becomes important if I want to use multi-input devices. So what that basically means is instead of having 8 lines to represent 8 bits, I have one line, but I just tell the system that there's actually 8 bits in there. And I'll show you what that looks like. Adder subtractor circuits. So obviously as part of what we're doing, we want to create our own adder and subtractor circuits, but as we create some a little bit more sophisticated circuits, particularly as we create our own example of an ALU, we might want to be able to just use the adder and subtractor circuits because it's a little bit easier to implement. It definitely can get very cumbersome quickly when I have all of those complex gates, trying to get them all to fit in the page, and then we'll look a little bit at the multiplexer and the demultiplexer and how to use them. So up here I have my logism up and running. The first thing I want to show you is this one over here. This is actually the splitter circuit. And what's really interesting about the splitter circuit, and in fact I'm going to come down here and pull this section up. So you notice when I've selected it, I have this whole menu that shows up. In this particular case it's talking about the splitter. And I can set in here what the bit width is. So for example, it's set to 2 by default. Maybe I need to have 4. And essentially what that does is it's going to create 4 inputs that are able to come in. And I can do the same thing here. So this is how many are coming in that I'm going to have, and what's the fan out going to be. So you notice I've selected here 4, and what I see here is I now have 4 lines. So one coming in, one big line coming in from perhaps something, and it splits it out to 4 distinct lines. That means I can get access to any one of those bits and determine what it is or use it in some specific way. This ability to set the number of bits is available for all of the different gates. So for example, here I have a selection pin, and this is a thing that we've used before to kind of set a 1 or a 0 on a particular line. The problem is when we start building 4-bit or 8-bit circuits, it's very, very difficult to put all of these things in. So what I can actually do is I can go in and specify using this data bits value a certain number of bits that it has. And you notice how I just specified 4 bits, and what we see happening in this is that I now have 4 numbers. So if I wanted to set the bits on something, I can set all 4 of them and just have one line coming out of here. Makes it a lot easier. So this is the input pin. I have the same capability with the output pin. So for example, here I'm also setting it with 4 bits, and anything that comes to this guy, let me see if I can get this to do this right. You see where our output now is going to match our input. In fact, you'll get an error in logism if you are mismatched in the number of bits. So for example, I can do the same thing with the AND, NAND, or any of the other gates. And in this particular case, I can say that the bit size is 4, right? So that way, if I attach this to something, then it's not going to have an issue with it. We talked a little bit about the multiplexer and demultiplexer. Here's an example of the multiplexer. I have multiple inputs coming in, one input that's coming out. Okay, these right down here are my selection bits. Now what happens is is if I have more selection bits, then it gives me more inputs that I can select. So when I pick 2, I know that I have 4 inputs that I now have access to. And you can see that the number of bits in my selection just went up. Okay, and if I go from there to, let's say, 4, we can see that I have quite a bit larger number of input lines that I can use. And that same situation exists for the demultiplexer as well. So for example, if I go in and select 4 selection bits, we can see that I have it fundamentally changes the picture and the number of selection bits that I have available, so I can use that in my circuits. One of the other things that we talked about was the ability to use an adder and or a subtractor circuit. Here we know that the subtractor circuit we can identify because it has a minus sign on it. So hopefully these features will help you leverage logism.